All right, so in this video, we're going to go over the concept of elasticity of demand. So some quick definitions. A product is elastic if small changes in the price leads to a significant change in the demand. So if you change the prices a little bit, you're going to see a significant change in your demand. A product is inelastic if small changes in the price does not change the demand. Your inelastic products are typically products that, are necessities, right? Think of gas, food. Those things are inelastic because no matter how much the price change, we need gas and we need food. Anyways, so in mathematics, we're able to calculate something called an arc elasticity if the actual changes in the quantity and price are known. Okay, so the arc elasticity, all right, which we're going to denote as E sub A. It turns out that arc elasticity is the delta Q over Q1. That fraction is over another fraction, delta P over P1. And that entire fraction is going to be negative. And this delta notation, we should be familiar with it. We've seen it a lot in calculus. Delta Q is going to be Q2 minus Q1. So if you know the two quantities, delta Q is Q2 minus Q1. Delta P in a similar fashion is P2 minus P1. All right, let's see a quick example. Here we go. Suppose Q1's 5,000, Q2's 5,800, P1 60, P2's 54. They want us to calculate the arc elasticity. Here we go, folks. E sub A, let's make this a little darker. E sub A equals, well, the formula is delta Q over Q1. That entire fraction is then over delta P over P1. And the entire fraction is negative. All right, let's see. So first of all, let's go ahead and calculate the delta Q's and the delta P's. So delta Q is going to be Q2 minus Q1. So for us, that's going to be 5,800 minus 5,000. And that's where we get a delta Q of 800. Delta P, P2 minus P1. 54 minus 60. It's always P2 minus P1 and Q2 minus Q1. That gives us a difference of negative 6. Okay, with that information, now we're ready to plug it into the arc elasticity formula. The arc elasticity equals, you take delta Q. Delta Q for us is going to be 800 over Q1. Remember, Q1 is the 5,000. All over delta P, negative 6 over P1, which is the 60. And don't forget the overall fraction is negative here. Or you're going to multiply by negative. Okay, so here we go. We're going to just simply go to our calculator. See if I have mine loaded up. Okay, I'm going to take 800. Divide that by 5,000. Okay. That gives me a 0.16. I'm going to put that in. So my numerator is a 0.16. Let's go ahead and calculate that denominator. It's going to be a negative 6 over 60. And that should be a negative 10%. But let me just double check. Negative 6 divided by 60. There we go, negative 0.1. So then the answer to this is a 0.16 divided by negative 0.1 and then make it negative again. So first of all, positive divided by a negative is negative. A negative times that negative that's out here, that's on the outside here, right here, that's going to still make it a positive. So then all we have to do is take a 0.16 divided by a 0.1 basically. Let's see, 0.16 divided by 0.1. And there we get 1.6. Positive 1.6. Okay, so that's your arc elasticity. Just a matter of following the formula, okay? So there's really no calculus involved with that. So when I said what I want us to focus on now is something called point elasticity. So point elasticity is the elasticity for a single quantity. We need calculus to calculate the point elasticity. Okay, why is that? This is very similar to how we first started talking about derivatives. I know it's been a while, but if you recall, we started off with the difference quotient. We said the difference quotient is just an average rate of change. Well, that's similar to what the arc elasticity is. Well, now for point elasticity, it's like we want to calculate the instantaneous rate of change. And if you remember, that's when we looked at derivatives. So it turns out that if you take the limit of the arc elasticity, you're going to end up with the following formula. Before I do that, let d of p be your demand function. Okay? So d of p means, demand means how many units you're going to sell. And so d of p is how many units you're going to sell at a given price. So if you know the demand function, then the point elasticity is the following formula. It is a negative p times the derivative of that demand function over the original demand function. And just a little side note here, the point elasticity is also called the elasticity of demand. So if you see that, it's just point elasticity. Okay. So before we jump into calculating the point elasticity, I want us to first of all practice getting the demand function. Okay. Here we go. For example here, we have our price function. So remember, little p is price. We have our price function is 500 over x plus 2. They want us to calculate the demand function. Remember, the demand is how many units that you sell. So all this means, and anytime it says solve for the demand function, it just means solve your equation for x. Okay? Here we go. I'm just going to rewrite this. So our price function is 500 over x plus 2. Okay, I need to solve for x. Let me get a different color here. So to solve for x, first of all, to get rid of a fraction, I'm going to multiply both sides by the denominator. For this, that means I'm multiplying both sides of the equation by x plus 2. Multiplying both sides of the equation by x plus 2. So what that means is that we now have, on the left side, it's just going to be x plus 2 times p is equal to, well, the beautiful thing is that the right side is going to cancel out, and we're left with just 500. We are trying to solve for x. So that means next I'm going to divide through by p on both sides. Got to keep that symmetry. And we are left with, on the left side, we're left with x plus 2 is equal to 500 over p. And the last step is subtract 2 from both sides of your equation. And here we go. We get that x is equal to 500 over p minus 2. In other words, come up here, our demand function, d of p, equals 500 over p minus 2. So the number of units that we sell based off a certain price follows this equation, 500 over p minus 2. The question didn't ask for this. Let me quickly show you what does that mean. So let's consider this. This is what we're going to do. Interpret let's say d, sorry about my handwriting, d of, let's say, 100. Okay. So what does this mean? Function notation. This means, remember, this is d of p. So that means everywhere we see a p, we're going to plug in 100. So here we go into the function that we just calculated. So d of p is going to be 500. Let me change this. D of, let's do this. D of 100 equals 500 over 100 minus 2. 500 divided by 100 is 5. 5 minus 2 is equal to 3. So what does this mean? When you say D of 100 is 3, that means that for this particular product, just for this product, we will sell 3 units at a price of $100. Remember, we plugged in 100 for P. That's what that D of P function is telling you. Demand means how many are you going to sell. Okay, really quickly, one more example. P equals 500 over x squared plus 5. Once again, they want us to find the demand function. So to do that, we're just going to subtract 5 from both sides. That's going to be your first step. So P minus 5 is equal to 500 over x squared. We're trying to solve for x. So as I told you guys previously, to get rid of that fraction, we're going to multiply both sides by x squared. We're doing it on the right side, and you're doing it to that entire function on the left side. Okay. So we have x squared times P minus 5 is equal to just a 500 on the right side. Trying to get x all by itself. So we're going to divide both sides by P minus 5. And on the left side, we are left with an x squared equals 500 over P minus 5. And there's one last step. We have an x squared, but to get an x, we need to take a square root. So we're going to square root both sides, right? When we square root, let's do it like this. When we square root the right side, let me do a different color. We square root the right side. Don't forget your algebra tells you that you're going to have both a plus and a minus root. But keep in mind, this is a business application. It's demand. I can't have a negative amount of a product. So for that, we're going to exclude the negative root. So that means that for us, our demand function will be the positive square root of 500 over P minus 5. Okay, so D of P equals exactly that. Square root of 500 over P minus 5. Okay, so I think we did that to death. So that's how you calculate the demand function given a price function. All right, with that being said, now we are able to find the point elasticity. For example, determine the point elasticity of demand for the following demand function. So to recap, point elasticity, this is the notation we use. E of P is a negative P times the derivative of your demand over the original demand function. Okay. Well, for this one, we're ready to roll because they already give us the demand function. We don't have to solve for anything. So what I like to do is I like to go ahead and quickly calculate my derivative because I'm going to need that for my point elasticity formula. Well, d prime of P, okay, don't let the extra letters fool you. The derivative of 250 is 0. The derivative of a negative P squared is a negative 2P. Here we go. So that means that the point elasticity is a negative, just following the formula, negative P times a negative 2P all over the original demand function, which was 250 minus P squared. Just going to clean this up a little bit. In your numerator, it's a negative P times a negative 2P. That's going to be a positive 2P squared over 250 minus P squared. That, folks, is our point elasticity. Okay. All right. So now we're getting to really the usefulness of this whole concept. For example, using the previous point elasticity function, determine if the product is elastic, inelastic, or unitary. Before we do that, let me just give you some quick notes. How do we know if something's elastic, inelastic, or unitary? If something is elastic, This is how you're going to know. If your point elasticity function, once you plug in that price, if it ends up giving you a value that's greater than 1, then that means that your function, the product, excuse me, the demand is going to be elastic. If your point elasticity, once you plug in your price, if it's less than 1, we say that the product is going to be inelastic. And lastly, if your elasticity equals 1, the point elasticity, then we say that the product is unitary. Okay? All right. So here we go. So I'm just going to go back and grab the previous elasticity that we calculated. It was, let's see here, 2p squared. So let's go different color here. So if y'all recall, E of P was 2p squared over 250 minus p squared. Let me double check. Now all we have to do is calculate E of 5. They tell us do it for a price point at 5. So E of 5 equals 2 times 5 squared over 250 minus 5 squared. 5 squared is 25. 25 times 2 is 50. Over 250 minus 25 is 225. And so to get our value here, we're just going to take 50 divided by 225. And we get a 0.22. It goes on forever, so let's just round it to 2 decimal places, 0.22. So approximately 0.22. And so is this product going to be elastic or inelastic? Well, if it's 0.22, that is less than 1, then we can say that the product is inelastic because its point elasticity is less than 1. Okay. And there's going to be certain questions where they're going to ask you for more than that. They're going to ask you, okay, once you figure out if you're elastic or inelastic or unitary, should you raise or lower your price in order to increase your revenue? So here's a quick discussion on that. If a price is elastic, remember that means that small changes in your price will affect your demand. And as you guys know, as price increases, typically demand decreases, right? So if your product is elastic, what you want to do is you're going to want to lower your price in order to increase your revenue. You're going to want to lower the price to increase your revenue because as you lower the price, you're going to have more people buy your product. If you're inelastic, inelastic means if you move your price up a little bit, the demand's not going to change. People are still going to buy it at pretty much the same rate. Well, in that case, you're going to actually raise your price. To maximize your revenue or to increase your revenue. Because if you're inelastic, that means I can raise it up a little bit and I'm going to still have the same amount of people come in. But that's not true for elastic. And then lastly, unitary. That's the case where you're going to leave your price alone because this is going to give you the maximum revenue. This is the sweet spot. So this price, leave this price alone. Okay? All right, so that's how you know to lower, raise, or keep your price the same as if it's elastic, inelastic, or unitary, respectively. All right, sorry for the length of this video, but let's keep it moving. One more example here. Determine the product with the following demand function is elastic, inelastic, or unitary at a price of $23. Okay. Here we go. So just to recap, the point elasticity formula is a negative P times the derivative of our demand over the original demand. And so what I would recommend here is I'm going to rewrite this demand function as 500 times p to the negative 1 minus 2. Just makes it a little easier to take the derivative. D prime of p will then equal negative 500 p to the negative 2. And now we can calculate the point elasticity. It's going to be following the formula. A negative p times a negative 500 times p to the negative 2 all over 500 p to the negative 1 minus 2. Okay. What I'm going to do next to kind of make this look a little nicer is I'm going to go back and all those negative powers, I'm going to rewrite them as a positive power, which means move them to the denominator. So my numerator is going to be a negative p times a negative 500. The 500 has to stay up top, but I can move that p to the negative 2, move it to the bottom, and there's the p squared. Now it's a positive 2. Over, now the denominator, we're going to rewrite that as 500 over p minus 2. And then in our numerator, that negative p is going to cancel out some of that p squared in the denominator. And a negative times a negative is going to be a positive. So the numerator is going to reduce to a positive 500 over p. Over 500 p minus 2. And here we go. Now E of 23. That's going to be 500 over 23 all over 500 over 23 minus 2. These are not going to be pretty numbers. Let's go ahead and do it. Let's clear. We're going to take 500. Where am I at? I'm going to take 500, divide that by 23. There we go. We got 21. Let's do 2 decimal places. 21.74. So we're going to have 21.74 over 21.74 minus 2, which gives us 21.74 over, let's say, 19.74. And then that is going to give us there we go. 1.10 if we go to 2 decimal places. So because our elasticity is greater than 1, that means that the product is actually elastic. And I know they didn't ask this, but if we were to make a suggestion to our boss about whether we should raise or lower prices, because we're elastic, we should lower the price. All right. Okay. I think there's just one more example. All right. Here we go. Last question. Where is it at? There it is. Go away. Okay. Determine the price that maximizes the revenue of a product with the following demand function. So if you guys recall, a few minutes ago, we said that, look, whenever the elasticity, the point elasticity equals 1, our revenue is maximized. So what we have to do is find the point elasticity, set that equal to 1, solve for P. That will give us the price that gives us the maximum revenue. And of course, we want to maximize our revenue. Here we go. So some derivative reviews here. The first thing I would do is I would rewrite the square root of 100 minus 2p as 100 minus 2p raised to the 1/2 power. So that means that d prime will be chain rule 1/2 100 minus 2p now raised to the negative 1/2 times a negative 2. And then let's go ahead and clean this up a little bit. I know we typically don't. Let's go ahead and clean this up. 1/2 times a negative 2 gives us a -1. A -1 times 100 minus 2p to the -1/2 power. And let's say we wanted to have a positive power, right? So we're going to move that 100 minus 2p. Let's move it to the denominator. So in the numerator, so I have a -1 over 100 minus 2p to the 1/2 power. And what is the 1/2 power? It's the square root. So I know that was a lot of work, but we're just trying to get this nice and neat because in a second we're going to have to plug in some numbers. Or excuse me, we're going to have to solve for this function. So I think it's easier to solve for if it's in square root form. Okay, so that is our d prime of p, but that's not our point elasticity. That formula is E of p equals -p times d prime of p over d of p There we go. So for us, that means that the elasticity equals a -p times a -1 over the square root of 100 minus 2p all over the original demand function, which was, if you remember, it was 100 minus 2p, the square root. So square root of 100 minus 2p. Once again, that original demand function, there it is. Okay. Let's clean this up. This is looking crazy. Okay, in the numerator, do a different color, kind of help you guys see this. In the numerator, a -p is going to multiply that -1. So the numerator is going to become a positive p over the square root of 100 minus 2p. And then this is all over the square root of 100 minus 2p. Okay, let's be clear. That is our point elasticity. Now let's find the price that maximizes our revenue. To do that, as I said in the hint, what you're going to do is you're going to take the point elasticity, p over square root of 100 minus 2p over the square root of 100 minus 2p. You're going to set that equal to 1. Set it equal to 1. Okay. How do we solve this? We're now trying to solve for p. How do we solve this? Well, we need to now, multiply both sides by your denominator. Trying to get rid of that fraction. So multiply the right side of the equation by 100 minus 2p, the square root of that, And also multiply the left side of the equation by, let's see if I can squeeze it in here. Square root 100 minus 2p. Sorry for the cramped handwriting there. Left side. Those are going to cancel. So on our left side of our equation, we're going to be left with just p over the square root of 100 minus 2p. That's that denominator of that complex fraction there. Equals on the left side, we're left with just square root of 100 minus 2p. Trying to solve for p. In order to do that, once again, got to get rid of another fraction. It's another fraction. How do we do that? Same process. Multiply both sides by the denominator, which is once again the square root of 100 minus 2p. Left side, finally, is left with just a p. The right side, when we take the square root of 100 minus 2p and multiply it by itself, it's going to cancel out those square roots, and we're left with just 100 minus 2p. And folks, we're finally at a point where this is starting to look a little better. Add 2p to both sides. P plus 2p is a 3p. That's equal to 100. Lastly, divide both sides by 3. And we get that p is equal to 100/3, which is, I don't need the calculator, that's $33.33. Okay? So, in order for them to maximize their price, or their revenue, they should sell their product at a price of $33.33. That's 100/3. Okay, I know it's a little bit on the long side, but I hope this helps you guys with the concept of elasticity. See you in the next video.